All right, Math 2, here we go. We've got lesson 1-2. We're going to be reviewing the parallel line postulates. Make sure that you're putting your name and your period up there. Today's question is, pretend there wasn't anything called the alternate, that should say exterior. Let's change that. Sorry. Let's pretend that there wasn't something called alternate exterior. My bad. Alternate exterior angles. How could we prove that angle 1 is going to be congruent to angle 8? Because it will be. So angle 1 and 8 should be congruent to each other. Alternate exterior angles tells us that's true. But let's pretend we didn't have alternate exterior angles. How could we prove that angle 1 is congruent to angle 8 using all the other angle relationships that we've learned already? The ones from lesson 1-1 and the lessons from today. So figure out, it's going to probably take 2 steps, but how could you prove that 1 and 8 are congruent using some of our other reasons that we've come up with? All right, so first off, we're going to start with just this diagram. This diagram has 2 lines, M and N, and it says here that M is parallel to N. That's the symbol for parallel. So usually to show that, we will put an arrow on M and an arrow on N, and that shows that those 2 lines are parallel. Now we've got another line that's crossing those 2 parallel lines. When you have a line crossing 2 other lines, that line is called a transversal. And then if you remember from last year, a whole bunch of things start becoming true because of those 2 lines being parallel. But this only works when they're parallel. So we have 4 kinds of angle pair relationships that we're going to need to remember, and they pop up in other units that we do too, so it's kind of good to know them. Let's start off with corresponding angles. All right, so corresponding angles. I'm just going to use the angle symbol there for corresponding angles. All right, what's the definition of corresponding angles? Well, a few things have to be true for angles to be corresponding angles. The first thing that has to be true is it has to be the same side of the transversal. Same side of transversal means 1, 3, 5, and 7 are on the same side of the transversal, and 2, 4, 6, and 8 are on the same side of the transversal. So you got this side of the transversal, the odd numbers, and this side of the transversal, the even numbers. So whichever corresponding angles, and we're looking at pairs of angles, they have to be on the same side. Either they have to all be on this side, or they have to both be on this side. So that's the first thing. Next thing is that 1 is an interior angle, and 1 has to be exterior. Let's see right here. So where's the interior and where's the exterior? Well, all along here is the interior. So between M and N, that's the interior. So when we say interior, we're saying between the 2 parallel lines. And so the exterior would be on this side and this side. So 3, 4, 5, and 6 are interior angles. 1, 2, 7, and 8 are exterior angles. All right, the last rule is they have to touch, or they're made from different lines. So let's find our corresponding angles here. Okay, so I'm just going to start with angles on this side. Let's say angle 1. Angle 1 is an exterior angle. So to be corresponding, the other angle would have to be on the same side of the transversal. And if this one's exterior, the other one would have to be interior. Well, I've got two interior angles on this side of transversal. I've got angle 3 and angle 5, but only one of those is corresponding to angle 1. The one that we're going to look at is angle 5. Now, why not angle 3? Because of this one. Angle 1 and angle 3 are made from the same two lines. They're both made from P and M. So we can't make the same angles from the same lines. So angle 1 is made from P and M, so it has to be angle 5, made from P and N instead. So now we know that, let's see, get a different color here. We know that angle 1 and angle 5 are corresponding angles. One's on the exterior, 5's on the interior. They're both on this side of the transversal, and they're made from different lines. Now also, 3 and 7. 3's on the interior, 7's on the exterior. They're on the same side of the transversal, and they're made from different lines. So angle 3 and angle 7. On the other side, 2 and 6. 2's on the exterior, 6 is on the interior. They're both on the same side of the transversal, and they're made from different lines. So we got angle 2 and angle 6. And then the last pair of corresponding angles are angle 4 and 8. 4 is on the interior, 8's on the exterior, same side of transversal, made from different lines. Now there's something that we know from last year about corresponding angles. Corresponding angles are congruent. And remember, congruence means that their measurements are the same. So if angle 1 was 110 degrees, angle 5 would also have to be 110 degrees. So these are congruent, these are congruent, these are congruent, these are congruent. All right, next one. Let's do same side interior angles next. All right, same side interior angles. Let's do this color. Put this up here. No, 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 don't die on me. Come on. Okay, got it. All right, so same side interior angles. So same side, that means that they're on the same side of the transversal, just like corresponding angles. So these are same side of transversal. Now this one says same side interior. So both the angles are interior. And these have to be made from different lines. All right, so let's find our same side interior angles. So same side of transversal and both interior. So 3 and 5 are same side interior angles because they're made from different lines. 3 is made from P and M, and 5 is made from P and N. So those would be same side interior angles. And then 4 and 6 over here would be same side interior angles. They're both on the interior, they're both on the same side of transversal, and they're made from different lines. So now we've got angle 3 and 5 and then angle 4 and 6. Now these ones are not congruent to each other. So this one said they're congruent. These ones instead are supplementary. And we found out last time that supplementary means that they add up to 180 degrees. So let's fix this. We can say that the measurement of angle 3 plus the measurement of angle 5 equals 180 degrees. The measurement of angle 4 plus the measurement of angle 6 equals 180 degrees, because same side interior angles are supplementary. All right, we got 2 more. Let's do alternate interior angles. New color. Let's do this one. I like this. Alternate interior angles. Okay, the name says it all. Alternate means different sides of the transversal. Interior means they have to both be interior angles. And of course, they'll be made from different lines. So the first thing that we know is different side of the transversal. Second thing we know is they're both interior angles, because it says alternate interior. And then the last one is they have to be made from different lines. All right, looking at what we have here, they're different sides of the transversal and both interior. So angle 3 is on this side of the transversal. Angle 6 is on the alternate side of the transversal. So 3 and 6, they're both interior. They're on different sides of the transversal, and they touch different lines. 3 touches P and M, 6 touches P and N. And then 4 and 5 would be alternate interior angles. They're on different sides of the transversal, that's the alternate part, and they're both interior angles. So far we've got 3 and 6. And then we've got 4 and 5. Okay, the thing that we know about alternate interior angles is they are congruent. They're the same measurement. There we go. So I can say that angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. Got to underline that. That doesn't look good. Oh, that's better. All right, last one. Oh, what color should I do now? Orange. No. Light blue? No. Teal. All right, so here we go. Alternate exterior angles are our last one. Now, alternate exterior angles. Alternate means different side of the transversal. Exterior means they're both exterior. Let's go back to the picture. Okay, so 1 is an exterior angle. The one on the different side of the transversal would be over here, 8. So 1 and 8 are alternate exterior. They're both exterior on different sides of the transversal. The other one we have is 2 and 7. They're both exterior angles and they're on different sides of the transversal. And remember, these all have to touch different lines. They have to be made from different lines. So we know that alternate exterior means different sides of the transversal. That's the alternate word. We know that they're both exterior. Move it up so you can see it. We know that they're made from different lines. And finally, these ones are also congruent. They are congruent. So our alternate exterior angles were angle 1 and angle 8. So angle 1 has to be congruent to angle 8. And we know that angle 2 and angle 7 are alternate exteriors. So angle 2 has to be congruent to angle 7. All right, so these are the definitions. When you get back to class, we'll actually work with problems that use these definitions. Remember, when they say congruent, that means that they are equal to each other in measurement. And when they say they're supplementary, they're going to add to 180. So we're going to need to keep that in mind. Now, your question that you're supposed to answer at the end of your notes are, let's pretend there's no such thing as alternate exterior angles, okay? And we know they're congruent. So if we didn't know that, how could we still prove that angle 1 and angle 8, which are alternate exterior angles, how could we still prove it without using alternate exterior angles? So you might use some of your other angle pair relationships here, or use some of your angle pair relationships from the previous lesson, lesson 1-1. You're going to need one from one and one from the other, just so you know. It'll probably take you 2 steps to do that. All right, so write that out in some kind of sentence, and we'll check back up on you later. All right, thank you very much. Bye-bye.